Hello, hi, good morning students. So myself Mubarak. So in this lecture we are going to discuss the objective questions related to the alcohols, phenols and ethers. So here is your first question. So in this question you can see an alkene obtained by the dehydration of the alcohol A on ozonolysis gave 2 molecules of acetaldehyde for every molecule of alkene the alcohol A is. So what they are saying, so from alcohol A is an alcohol. So on alcohol A, what they have done the dehydration, they have removed the water. So after removing the water, they got one alkene. They have obtained one alkene as the product. So on this alkene, they have done ozonolysis. On this alkene, they have done ozonolysis. When they have done ozonolysis, they have got the 2 molecules of acetaldehyde. That is, they have got CH3 C double bond OH. So they have got 2 molecules of acetaldehyde. So what is this alcohol? So question is, what is A? So what is the alcohol here? So we already know, so from acetaldehyde, so we have to guess. So what is the alkene? From alkene we have to guess A. So I'll start with the acetaldehyde. Okay. So I will write the 2 molecules of acetaldehyde. So this is the first molecule of acetaldehyde and I have written the second molecule of acetaldehyde. So how to write an alkene? So very simple. So you have to remove this 2 oxygen atom, connect the remaining 2 carbon atom with the double bond. This 2 carbon atom you have to connect with the double bond. So what alkene you will get? So you will get C double bond C, and on this carbon you are having H as well as you are having the CH3, and on the left hand side carbon you are having H as well as you are having the CH3. So what alkene? Also alkene is 2-butene. Alkene is 2-butene, so it may be cis or it may be trans, cis 2-butene or trans 2-butene. So both will give the 2 molecules of acetaldehyde. So coming to the A, so what is A? So A is an alcohol. So which type of alcohol will give 2-butene? So it should be the secondary alcohol. For example, here what we have to do is, so on one carbon you have to add the H, and again on another carbon you have to add the OH. Why? Because you have removed the water from the alcohol. So product is actually the alcohol A is CH3 CH2 CHOH CH. So this is the alcohol. So what is its name? Its name is butane 2-ol. Butane 2-ol. So which is the right answer here? So right answer is D. D is the right answer. So coming to the second question. So here Z reacts with the phosphorus tetrachloride to give the X. X reacts with the alcoholic KOH to give the Y. Y reacts with, first of all, with concentrated H2SO4 and boils with the water and will get Z. So what is Z? Okay. So what is Z? Z is, okay guys, let us consider A is a Z. For example, if Z is CH3 CH2 CH2OH, let us consider Z is propane 1-ol. So when it reacts with the phosphorus pentachloride, so what is the role of phosphorus pentachloride? Phosphorus pentachloride will replace the OH with the Cl, and the product is this CH3 CH2 CH2 and Cl. Okay, so this is X. So when it is reacting with the alcoholic KOH, so what is the role of this reagent? So this reagent is used for dehydrohalogenation. So here, from here I have to remove the HCl. So after removing the HCl, so I will get the product CH3 CH double bond CH2. So here only I am getting Y again. Here only I am getting Y again. Okay, so to this is Y. To this, if I am adding the concentrated H2SO4 and I am boiling the water, so it's just like adding the water in presence of H plus. So what I will get? So I will have to add the water according to the Markovnikov rule. That means OH I have to add to the less number of carbon atom, and H I have to add to the more number of carbon atoms. So I got this, but here you can see this jet I didn't got back. So if I start with B, that's a 2 propanol. If I start with B, I will start with this CH3 CHOH. Here it is CH3. This reacts with the phosphorus pentachloride. So here this OH will get replaced with the halogen. I will get CH3 CHCl and CH3. This is the product X. So this further reacts with alcoholic KOH. So alcoholic KOH is used for dehydrohalogenation. From here I will remove the HCl. So I will get the product CH3 CH double bond CH2. So this is the product Y. So this is product Y. So on this product Y I am adding the water in presence of acid. I'm doing the hydration. So according to Markovnikov rule, OH will be added to the double bonded carbons which is having less number of hydrogen. So I have to add OH on CH and H on CH2. Okay, so I got jet back. The right answer is B. B is the right answer. So which one of the following is not the characteristics of the alcohol? Which is not the characteristic of the alcohol? First point. So their boiling point rise fairly uniformly with a rise in the molecular weight S. So it is the right statement. It is the right statement because as the molecular weight of the alcohol increases, their boiling point will be increased. Next, the lower members have the pleasant smell but burning taste, and the higher ones are the odorless and tasteless. Yes, the lower members of the alcohols will have the pleasant smell but burning taste will be there, and higher ones are odorless and the tasteless. Higher alcohols will not have any smell. It is also the characteristic of the alcohol. Third, so these are the lighter than the water. Yes, alcohols are the lighter than the water. Next, so fourth point, lower members are insoluble in the water and organic solvents, but the solubility goes on increasing with rise in the molecular weight. So this statement was wrong. So solubility will never increase, will rise in the molecular weight, it will be decreased. So here it is not the characteristic of the alcohol. So lower members are insoluble in the water, it is wrong. Lower members are soluble in the water, insoluble in the organic solvent, but the solubility goes on decreasing with rising in the molecular weight. So A, B, C are the right statements. Option D is not the characteristics of the alcohol. So coming to the next question, A reacting with the dilute H2SO4 in presence of mercury, it given 1-methyl cyclohexanol. First I will write what is 1-methyl cyclohexanol. Cyclohexanol, so that means you are having the 6 carbon in the cyclic form, and on one carbon you are having the methyl, again on the same carbon atom you are having the OH. So this is 1-methyl cyclohexanol. So to 1-methyl cyclohexanol is obtained from A by adding dilute H2SO4 in mercury station. It is like adding the water. So what could be A? A could be two things. So yeah, it is very simple. A is an alkene. From here I will remove the OH. So this is the alpha carbon, this is also, sorry, this is alpha, and this carbon is beta, and this carbon is beta. So you'll have the two chances. One is A could be this alkene. Okay, so another one is A could be have the double bond inside the ring like this. So both will give the same product on addition of dilute H2SO4 in presence of mercuric ion. So you will get the 1-methyl cyclohexanol. So the right answer is D. D is the right answer. So coming to the next question, 2-phenyl butane 2-ol can be prepared by which of the following combination? So first I have to write the structure of 2-phenyl butane 2-ol. So the root word is but, that means it is having the 4 carbon atoms, and on the second carbon atom it is having the phenyl. So I will write C6H5, and again on the second carbon atom it is having the OH. So now it can be prepared from what? It can be prepared from an ketone. So which alcohol it is? It's a tertiary alcohol. So to prepare the tertiary alcohol, we have to use the ketone. Along with the ketone, any one Grignard reagent like R, M, G, X. Okay, so this is the starting material of to prepare the tertiary alcohol. So there is the number of chances to prepare this. For example, if I break H here and if I break H here and this part, so if this part will come out in the form of CH3, CH2, this will come along with the Grignard reagent like CH3, CH2, MgBr. So one you will get methyl magnesium bromides. Another one is here you will get the ketone that is CH3, C double bond O, C6H5. You will get the H2 phenol. So this is the first chance. So second chance is if I break the bond here, so one side you're having the methyl, so that methyl will comes and attack in the form of methyl magnesium bromide, and so here left over with the ketone part, that is you will get C6H5, C double bond O, C2H5. So this is ethyl phenyl ketone. So what is it? Third chance is break this phenyl. So this phenyl can come along with the Grignard reagent in the form of C6H5 MgBr. Now the leftover part is this ketone. So leftover part is the ketone part. So it is like CH3 C double bond O, C2H5. So you can see option A, C6H5 CO CH3 C2H5 MgBr. So you can see this is the first option, C2H5 CO CH3 C6H5 MgBr. So you can see this third one, and C6H5 CO C2H5 and CH3 MgBr. So the second option. Okay, so you can prepare the 2-phenyl butane 2-ol by using all this method. Next, the correct structure of the compound B is, I'm starting with the alcohol. Okay. So here they had given the secondary alcohol. So first of all we have reacted with the phosphorus tribromide. So what is the role of phosphorus tribromide? Phosphorus tribromide will replace the OH with the Br. So wherever OH was there, in that place I have written the Br. I got the 2-bromobutane. This after I am reacting with the magnesium, it is an insertion reaction. To prepare the Grignard reagents, I will get one Grignard reagent like this. So between Br and that alkyl group, I have to write the Mg. I will get the MgBr. So this is A. So this is the product A. So this they are reacting with what? Methyl CH3, CH2, CHO. So if I consider this like this, okay. So this is the Grignard reagent. This I am reacting with CH3, CH2, C double bond OH. So how to write the product? Very simple. Okay, so because of this magnesium is attached to the carbon, this carbon will get the negative charge. This will go and attack on the carbon. Actually there should be one hydrolysis concept. Okay, so you will get, so this part is from the Grignard reagent. This was attached to the carbon. On this carbon is you will get the OH. Now already you are having H on this carbon and CH2 CH3. This is the answer. So what is the answer? You can see its name is, which is the right one? Right one is, okay. So option B is the right one.